The objective of this video is to learn what is logarithmic differentiation and how to use it. Let's start with the following example. So we have a function y, which is a function u of x to the power function g of x. And the question is to find dy over dx, the first derivative of function y. Now, there is no rule that gives the derivative dy over dx because g of x is a function of x, is not a constant. The method of logarithmic differentiation has got 3 steps. The first step in logarithmic differentiation is to take the ln, natural logarithm of both sides. So ln of y is equal to ln of u to the power g. Then use the property of logarithm to rewrite the right side as a product. The second step is to differentiate both sides with respect to x. So d over dx ln y is equal to d over dx, the right side g ln of u. Now the left side is a composite function. It's an ln function of y of x. So we use the chain rule that will give 1 over y dy over dx. The right side is a product of 2 functions, so we use the product rule g prime ln of u plus g 1 over u prime. We now multiply both sides by y to obtain dy over dx is equal to g prime ln u plus g over u prime multiplied by y, which gives g prime ln u plus g over u prime, and y is given as u to the power g. We are going now to apply the above to a specific example. So with u and g given, so the example number 1 is to find the derivative of the function y equal to x2 plus 1 to the power x. So find dy over dx. Step 1, we take the ln of both sides. So ln of y is equal to ln to x2 plus 1 to the power x. Simplify the right side. Differentiate both sides with respect to x. So the left side, chain rule for the left side, 1 over y dy over dx. The right side is a product of 2 functions, so 1 ln 2x2 plus 1 plus x. The derivative of ln 2x2 plus 1 is 1 over 2x2 plus 1 multiplied by 4x. We now multiply both sides by y to obtain the derivative of y with respect to x, which is equal to, and we also simplify, 2x2 plus 1 plus 4x2 over 2x2 plus 1 multiplied by y, which is 2x2 plus 1 to the power x. So the logarithmic differentiation was used in this case because the given function, it's a function to a power another function, and there is no rule to solve this, to find the derivative. Let's look now at another example, example number 2. Now example number 2, y is given by 2x plus 1 to the power 10 multiplied by the cube root of x2 plus 3. Now this function it's the product of two functions and can be differentiated using the basic rule of differentiation of functions. Let's see how we can use the logarithmic differentiation to differentiate these functions. So we start with the ln of both sides, ln y, equal to the ln of the product of the two functions, 2x plus 1 power 10. And then the cube root is written as x2 plus 3 to the power 1 over 3. So it's the ln of product. We use the property of the logarithm that gives ln 2x plus 1 power 10 plus. So we go from product to a sum. Again, we use the property of the power that gives 10 ln 2x plus 1 plus 1 over 3 ln x2 plus 3. Now we differentiate both sides. So the left side is a composite function, so the derivative with respect to x will be 1 over y dy over dx. The right side is the sum of two functions, so that will give 10 1 over 2x plus 1 multiplied by 2 plus 1 over 3 1 over x2 plus 3 times 2x. Multiply now both sides by y and simplify to obtain dy over dx equal to 20 over 2x plus 1 plus 2x divided by 3x2 plus 1. Now all this multiplied by y, or 10 cube root of x2 plus 3. We now look at another example number 3. In example number 3, we are going to consider a function which is given by the product of three functions. So y equal x2 plus 1 to the power 9 multiplied by the square root of 2x plus 1 multiplied by 1 over x minus 1 power 3. So this function is the product of three functions. Again, the basic rules of differentiation may be applied. However, many steps will be involved. Now let's see how we can use the logarithmic differentiation, and later on as an exercise you can compare the two methods. So we start by taking the log of both sides. So ln y is equal to ln x2 plus 1 power 9 plus ln square root 2x plus 1 minus ln x minus 1 power 3. Now we use the power rule of the logarithm to rewrite the above as ln y equal 9 ln x2 plus 1. The square root is power half, so it's half ln 2x plus 1 minus 3 ln x minus 1. We now differentiate both sides. So the left side is a composite function, so it's 1 over y dy over dx. The right side is a sum of three functions, so it's 9 1 over x2 plus 1 multiplied by 2x plus 1 half 1 over 2x plus 1 multiplied by 2 minus 3 1 over x minus 1 multiplied by 1. We now multiply both sides by y and simplify to obtain dy over dx is equal to 9 and 2x, that gives 18x over x2 plus 1 plus 2 and 2, 1 over 2x plus 1 minus 3 over x minus 1. Multiply all this by y, the given function, x2 plus 1 power 9 square root 2x plus 1, and multiplied by 1 over x minus 1 power 3. Now we can see that this method is much more efficient than the method of using the basic rules of product and power rules.